Hello, and welcome to Lab 2 Motion of a Falling Object by Jack Ingram. Introduction. For this lab, we will be tracking the motion of an object falling a short distance from rest. In my case, I will be using a small pillow. We will use Tracker to observe the motion and create a Python program in GlowScript to try and model the motion of the object. We will be using Newton's second law, both with and without taking drag force into account. For the purpose of our lab, we will only focus on two forces: the weight force caused by gravity and the drag force. The drag force is in the opposite direction of the weight force. We know that the net force is equal to the force done by gravity plus the drag force. The respective equations are listed here. We know that G is our gravity constant of 9.8 meters per second squared, and B is our drag constant. Here is the video of me dropping the pillow in Tracker. Using Tracker's point mass feature, I was able to track the motion of the pillow as it fell through the air. If you look in the top right, you can see the position versus time graph in the y direction. Below that, you can see the data with the x and y data. However, we are only worried about the y for the purposes of this lab. Here are the observations we made using Tracker. We tracked the pillow from the time 0 to 0.601 seconds. The y position changed from negative 1.93 meters to negative 1.612 meters, falling a distance of just over 1.4 meters. The x position had virtually no change as we were attempting to drop it straight down. The mass of the pillow was about 0.5 kilograms. The goal of this lab was to create the two computer models. We'll start with the force of gravity only model. To create this model, we used a starter code from Canvas and made the necessary adjustments. The first of these, you can see with the top arrow, is we updated the ball's initial position. At the bottom, you can see we've updated our while loop to fit only the time that it took the pillow to hit the ground, and we also updated the equations for the force of gravity, net force, the velocity, and the position of the ball. Here's what happens when we run this model. Here we are comparing the observation and the chart produced from Tracker with the graph produced by the force of gravity model. You can see that there are similar curves on both charts, but the model predicted that the pillow would drop further than it did in the time allotted. This is because the only force this model took into account was the force of gravity. This next model takes both the force of gravity and the force of drag into account. You can see the code is very similar to the previous model, but we have added in the force of gravity and also added that to the net force equation. Here's what happens when we run this model. This chart shows all three curves. Looking at this chart, you can see that the force of gravity model predicted the object to drop the furthest in the allotted time. This is because there is no force pushing up on the object in this model. As you can see, our observed trial and the force of drag and gravity model came to very similar conclusions. What are some possible locations of error? One of the possible locations of error is the inability to perfectly place the cursor on the center of mass in Tracker. The pillow I use as my object is also not uniform. I am not sure of the exact correct B value to use, which could mess up the model that used both the force of gravity and the drag force. Next, we will discuss how terminal velocity affects this lab. The model that incorporates the drag force would reach a terminal velocity if we let it run for long enough. However, the model that does not incorporate the drag force will simply continue to gain speed indefinitely, as the only force acting on the object is gravity. If you see on the bottom left, this is the force of gravity model only, and as you can see, it continues to have exponential speed increase forever and ever. On the right, however, you can see the velocity becomes linear after a while because of the terminal velocity. What if we were to throw the object down instead of just simply dropping it? Well, if we were to throw the object down, the object would still have the same terminal velocity. It would just reach this velocity more quickly. This graph looks similar to the one on the previous slide. However, it started with an initial velocity of negative 10 meters per second. Thank you all for watching, and I look forward to reading your feedback. I wish you all luck on this test this week.